Hi and welcome to the Week 2 live session. Well, this is actually just a video, but so we'll go over the assignments the problems that you'll see in your assignments. The assignments due this Sunday night is Quiz 2 and Test 2, and don't forget YouTube videos and my math lab for help. So first we look at what is an ordered pair. Now, ordered pair is a way that we write a point that we plot on the coordinate plane. So you can pick, you'll have multiple choice and you got to pick which one is the proper ordered pair format. So the first coordinate is your x-axis, is your point on according to the x-axis, and your second on the right side is the number according to the y-axis, and we'll see some of this on a coordinate plane in a second. And then we use these types of parentheses. So obviously A will be the answer. These kinds of brackets are used for something else. These and these in math, they mean totally something else. It's actually a language. And to have no parentheses at all, that means nothing to mathematicians. That's just a couple numbers with a comma in the middle. So that should be an easier question for you to grab up the points for. Now, on this problem, you'll have what are the coordinates of the points shown in the graph. And I put a bunch of points, but you'll be given one. So for the red dot, you can pause the video and write down the coordinates of all these points and see if you get them correct. Because this should be review, sort of. And so what we do is look at the red dot. The red dot's right here. And this is the x-axis. And this is the y-axis. So we're 4 units over on the x-axis, so our x is 4. And we're right on the x-axis, so the y is 0. And for the blue's down here. And it's right on in the middle for the x-axis, so that's at 0. And then it's down 5 units for the y, so that's at -5 for the y. For the orange, it's at 0 for the x, and up 2 units for the y. So it'd be 0, 2. And for the purple dot, you're looking at the x coordinate first, so it's over to the left 4 units, so that's -4, because that side's negative. And it's right on the x-axis, so that's 0 for the y. And the green dot's right in the center. That's also called the origin, so that'll be 0, 0. So that's precisely what you should have gotten, and you can see how you did. On the next point, on the next slide, same kind of question. I just moved the dots out a little more. So for the green dot, which is right here, now remember, pause the video if you want to try this yourself, which is a good idea. And then you can see how you did. So for the green dot here, we're over 5 units on the x-axis, and then up 1. So 1 on the y-axis. So did you see what I forgot in my answer? So you must have parentheses or else it'll be incorrect. And you've got multiple choice for all of your questions, or most. Now for the pink dot, which is down here. So hopefully you're not colorblind, but I'll point out where these are. So this is over 7 units on the x-axis, or 7 marks, or whatever you want to say, and then down 9 units, so that's -9 for the y. And for the orange, it's over to the left 4 units, so that's -4 for the x, and then up at 6 for the y-axis. And then for the blue dot, it's over -7 units on the x-axis, and down -3 for the y-axis. And then for the purple dot, it's over -5 units on the x-axis, and down 1 unit, so -1 for the y. So that's precisely what you should have gotten for those. Now what we look at next is the x-intercept. So you'll be asked what is the x-intercept of the graph. So you'll be asked just this on one graph, but I put a few for us to practice. So the x-intercept, see for this blue line here, the x-intercept for this blue line will be where it crosses the x-axis. Intercept is in math just like it is in football, interception. So that point is what you're going to answer, or what you're going to respond. What is the x-intercept? The x-intercept is at -2, 0, because that for the x-intercept anywhere, the y is going to be 0. So -2, 0. So you can take a look at these and try to answer before I do. Maybe pause the video. Don't forget to put your finger on the pause button anytime you want, just for this reason. And so here's the x-axis, and here's the purple graph, and you're just looking at where does that purple line cross the x-axis, and that's right here, and that's at 4, 0. And then for the for the red line, we're looking at where does that cross the x-axis, and that's right here, and that will be at 1, 0. Okay? Next thing we'll ask is, what is the y-intercept? And I just put the same 3 graphs there, so you could pause the video and see if you can guess what that means, the y-intercept for each of these. And so for this blue line, this is the y-axis, and the blue line crosses the y-axis right here at this point. And so that's the y-intercept, and that will be at 0, 4. So it's not only about pointing it out, but correctly writing the coordinates. And so for the purple line, you see where it crosses the y-axis right here. So that will be at 0, -2. And then for the red graph, the red line, the y-intercept's right here at this point. And so that will be at 0, 1. Always zeros, see, for the x's when you're looking at the y-intercept. And you always have zeros for the y's when you're looking for the x-intercept. Next, we're looking at the concept of slope. So slope is just like in math, it's just like in the real world, where we're looking at the tilt of a floor or a hill or something we're going to build, a ramp. It can be, a gradual slope. It can be a really steep slope. It can go down like this. Sorry, that should be a straight line. It can be totally straight, level. And so what we do is we calculate, we want a number to describe this slope value. So we can describe the slope precisely with a number. So like this would have some number, and this would have a large number slope, like a real number, numerical, one of our numbers. And this slope, of course, would be 0. So these would have positive slopes. This kind of thing would have negative slope. And the way that we measure a slope is all we have to go on is vertical, the vertical and the horizontal. We have the horizon with the sun, and we know gravity pulls us vertically. So we take sort of a ratio of each, and then we measure what slope is. And so this is the slope formula in which we do that. y2 minus y1 divided by x2 minus x1 equals m. M is slope. Okay, so we'll use that in problems on the next slides. And then you'll also see slope in this formula here. This is a general equation of a line formula, y equals mx plus b, which maybe you've heard of before. And slope is right here. So if we have an equation like this, which we'll see later, you'll be able to read the slope right off. That's all you need, 2. The slope is 2 for this line. Okay? So let's see what some problems look like. Well, I don't have anything on here. That means I was supposed to make some up. So you'll be given a problem like find the slope of these points, 1, 3, and 7, 5, or something like that. So these are 2 points on the coordinate plane that are plotted, and you have to find the slope of the line that connects those. So the first thing you do is write down the formula, and you're going to have these different formulas in what I call your toolbox or a sheet of paper. And you have to decide which formula is going to fit, or which tool is going to fit for your problem. So if they ask you the slope, well, then you can pull out the slope formula. So you write down the slope formula. Now I'm going to teach you again how to write your math work to reduce chance of error, because there is so much error that is easy for us to do just by accident with writing our math work. So you write down your formula. Right under it, you're going to plug things in. So I'm going to draw the division bar that comes with the formula, the subtraction signs that come with the formula, then I'm going to plug things in. Now y2 minus y1 means I'm going to plug in the y's, which are right here, 3 and 5. And the 1 and the 2 here just mean those are different y's. They could be the same number even. They just mean they come from different points. I've seen it as a and b, I've seen it as a and 0, 1 and 0, but most commonly 2 and 1. That just means that y2 is different than y1, although it could be the same number sometimes. And the same thing with these. That's what those subscripts mean. It doesn't mean an order that 3 has to come first and then 5, because there's no order in the universe. It's all arbitrary. We pick out and order things up because everything's just floating out there, right? So we'll put 3 and 5 in there. So just put your y's in the top and then your x's in the bottom, 1 and 7. It's just that these numbers above and below each other have to come from the same point. And these numbers above and below each other have to come from the same point. And then what you do is just simplify this. So 3 minus 5 is negative 2. 1 minus 7 is negative 6. And you have to reduce that. Negative and divided by negative is a positive. So that's 1/3. So the slope is 1/3 for the line. So we can see it would be a gradual slope, a little bit of a tilt. Okay, so we're going to do one other, because I have to make sure we get negative numbers in here. So what we do is write down the slope value, our slope formula, y2 minus 1 over x2 minus x1. Okay, and then right under it, we're going to plug things in. I write the division bar that comes with the formula. I write down the subtraction signs that come with the formula. Now I'm going to put my y's in the top, and I can put negative 2, negative 1, or I can put negative 1, negative 2. Doesn't matter. But then I have to make sure that these are correct on the bottom. So I'm going to put negative 1 first just to show you. So I just plugged in the y's, negative 1, negative 2. We put parentheses because there's two signs next to each other. It's kind of good penmanship to do that. And then since I picked negative 1 first, I got to pick the negative 3 first right here, and then the negative 6 here. And of course, parentheses right here. These numbers above and below each other have to come from the same point. See, these numbers above and below each other have to come from the same point. Otherwise, you'll get the slope value wrong. Now we just simplify. So what I'm going to do first is resolve or evaluate these signs so that my brain can see I really have negative 1 plus 2. And because two negatives next to each other make a plus. And then down here I have negative 3 plus 6. And I'm more likely to get this correct then. I'll just simplify this way. So negative 1 plus 2 is 1, negative 3 plus 6 is 3. That happens to be 1/3 as well. Wow, that's a coincidence. So whatever it comes out to be, that's what you do. That is a crazy coincidence right there. So now in this type of problem, we're going to find the slope of the line given the equation. You're not going to be given a whole table like this. You'll just be given one problem. But it's so easy that we're also going to look for the y-intercept while we're at it, by the way. And I provide us a lot of problems so we can really practice. So for the first one, we have our formula, remember our equations in y equals mx plus b form, remember. So this m is the slope, so you'll be able to read that right off the equation, and the b is the y-intercept. Okay, so for y equals 4x plus 6, the slope is 4. So I write down positive 4, so that the sign comes with that. See how the next one is negative 4? So that's going to be negative 4. So you just want to make sure y is totally by itself. There's not a 2y or something, because if there is, you have to do work to move that 2. And it can't be negative y. It has to be just y. And it has to be in mx plus b form. And then, so we'll go down and do the slopes first. So if you want to pause the video and run down and do the slopes, write down the slopes or on your paper and see how you do, that'd be a good idea. So all the slopes are right here in front of x. The coefficient of x, negative 2. The slope here is 50. The slope here is actually negative 1. The slope here is 13. The slope here is 7. It should be that easy. Run down and write those. Same thing for the y-intercept. It's b. So you're going to write down on this first equation just a positive 8 like that. The y-intercept is 8. It's really 0, 8. X is 0. You remember y-intercept is where that line crosses the y-axis. So that's where x is going to be 0. So you could write 0, 8, but you probably have multiple choice. So you can see how they do it. And then here, for the second one here, the y-intercept's negative 1. For this one, the y-intercept's 90. And if you haven't already, you can pause the video and run down and write these down and see how you do. So the y-intercept for this one is 100. The y-intercept here is negative 1. The y-intercept here is negative 8. And the y-intercept here is 2. And it's that easy, so you want to grab up the points for these easier problems because things get more complicated, and you want to leave the points that you maybe miss for more complicated things, where you really grabbed up the points for the easier problems because you slowed down and was real careful and made good notes for yourself. Now we have a problem where we write an equation for a line that passes through these points. And so we're going to actually write an equation of a line. So that means something like y equals mx plus b is going to be our answer. Something with an x and a y in it because we'll put the numbers in for m and b. But we don't know m and b, but what we're given are 2 points. What I know what I can do with 2 points is find the slope. So I'm going to pull that out of my toolbox to use and write it down. y2 minus y1 divided by x2 minus x1. And right under it, I'm going to plug in things. Write the division bar. And then draw the subtraction signs. Sorry, when my writing tablet moves, it's awful. And then I'm going to write the subtraction signs that come with the formula. Now I'm going to put in the y's here. So that's negative 3 and negative 1. You can put negative 1, negative 3, doesn't matter. But if I put negative 3, negative 1 first, I'm going to put negative 1 here first for the x's and negative 2 here. Okay, now I'm going to simplify. So I'm going to first resolve or evaluate these signs. Negative 3 plus 1, negative 1 plus 2. And then to simplify, this is negative 2 and this is 1, so that's negative 2. So the slope is negative 2. But we want the equation of the line, so far I can write my equation as y equals negative 2x. And then I need the b. I don't know what that is yet, but once I have that, I have the equation of the line. So what I can do is a couple different things. And a lot of people use y equals mx plus b to actually find that b value, which is just fine. I'll probably just do that. So what you do with that is we know the slope value and we need b. So we do have an x and y, and it could be either one of these points that you plug in. So I'll plug in negative 1, negative 3, what the heck? So that means negative 3 goes in for y, negative 1 goes in for x, and I'm going to find b. So I simplify. So negative 3 equals 2 plus b. Now I need the 2 to go over to this side. So that's going to become negative 3 minus 2 equals b. And that's negative 5 equals b. So that's what goes in here. So the equation is actually y equals negative 2x minus 5. And that's how you find that. So if you need to review that, just replay the video. Now I have a blank slide for some reason. And then here's another question that you'll have. Complete the ordered pair so that it is a solution of this equation. And you're given a part of an ordered pair here. Remember, ordered pair is x and y, so we're missing the y, but we're given the x value. So what I do is write down the equation that I'm given, 2x minus 2y equals 8. And x is 5. So 2 times 5 minus 2y equals 8. And we're going to solve for y. So this will be 10. I evaluate what I can right away. And so now we need the 10 and the negative 2 to be away from y. And those go over here to combine with the 8 so I can see what that value of y is. We kind of start with the 10 first, the number farther away from the y first. So I'll show you what I do step by step. I need that 10 to disappear from the left side and appear on the right side. And the way that will happen is if I subtract 10. And I have to subtract 10 from both sides. That's the property of equality. So that this makes 0. So I have negative 2y equals, and this is negative 2. So y is 1 there. Negative 2 times 1 is negative 2. So y is 1. So 1 goes right in here. Okay, and that's your answer. So now we have some equations here where we're going to solve the equation for y. So I put 3 of them here. So here we have x minus y equals 3. We want y by itself. The x needs to go away from y, and there's this negative 1 right here actually that needs to go away from y. We'll start with the x first. The x needs to disappear from the left side and appear on the right side. The way I'll make that happen is by subtracting x. I will subtract x from both sides. This is 0. So that means 0 minus y is just minus y. That's how that y minus y gets by itself. And this is 3 minus x over here. Now I have really that minus 1 that needs to go away from y. I'm going to write that again here, this whole line, so that I can work on it. This way this line is preserved. I can see what it was. So negative 1's being multiplied by y. I have to do the opposite operation and divide. And I do that to each term on both sides of the equation. These cancel out because they make 1. 1 times y is just y. That's how y gets by itself. Now I evaluate 3 divided by negative 1. That's negative 3. Negative x divided by negative 1 is positive x. And you might see in your multiple choice that it's y equals x minus 3, same thing. So that's that problem. Now for the next problem, we have 4x plus 2y equals 1, and we got to get y by itself. So I need the 2 away from y and the 4x away from y. I start with the 4x first. So I'm going to subtract 4x from both sides. This makes 0. 0 plus 2y is just 2y. So I have 2y equals 1 minus 4x. So now I need the 2 away from y, and it's being multiplied by y, so I have to do the opposite operation and divide by 2. And I have to do that to every term on both sides of the equal sign. These cancel because they make 1, and that means 1 times y is just y. So you have y equals 1/2 and then minus 2x. And you may see it as this, y equals negative 2x plus 1/2, which is the same thing. Now for the last one, we have 3x minus y equals 5. So there's a 3x and really this negative 1, because y has got to be positive. We're solving the equation for y, not negative y. So 3x minus y equals 5. And so I'm going to move the 3x first, make it disappear from the left side and appear on the right side. And so to do that, I will subtract 3x, and I'll do that on both sides. Because this is 0, that's what we want to happen. That's why I chose to subtract 3x from both sides. So we have negative y equals 5 minus 3x. And this is like negative 1y equals 5 minus 3x. Negative 1's got to go away from y. It's being multiplied by y, so we've got to divide by negative 1 and divide every term by negative 1. And those cancel and make 1, so that leaves y by itself. So what we have is y equals negative 5 plus 3x. Or y equals 3x minus 5, same thing. I hope that helped. So this is a problem where I might just do one of these, but you're asked to look at the graph and come up with the equation of the line. And you'll have multiple choice, but I didn't even bother putting multiple choices. So it's going to be, you can write it in some kind of y equals mx plus b form. And you know your y is going to be there and your x, because that's what varies. The thing that makes up a line, the things that make up a line are points. A bunch of points make up the line, a bunch of y's and x's. But the m is a certain constant number. The line's tilted the same all the way across along the line. And then the b is a certain constant number that never changes. Constant means it never changes. The b is the easiest thing to recognize on the graph. That's the y-intercept. That's right here at this point, and that's at negative 2. So negative 2 goes there. Now we just need to fill this part in. Now remember, for the slope, if you look at the formula, you just need 2 points. So if we can find 2 precise points that we're clear about on the graph, we can plug them in and find the slope value. Well, we know this point, we could use that, and we can use the x-intercept here if we want. So I'll plug those in. So that's at 0, negative 2, and that's at 4, 0. So what I do is write down the division bar that comes with the formula and the subtraction signs that come with the formula. The y values go in, so 0, negative 2, and then the x values go in under it, 4 and 0. And then I'm going to simplify that here, so I have 0 plus 2, and then 4 on the bottom. And then I'll make 2 over 4, which is 1/2. So the slope is 1/2. And that's the equation of that line on the graph. So you can review that video and see how I did that again. So for inequalities, you see inequalities. This is a problem that a lot of students get incorrect. So it's very important to practice this. And you have these on my math lab, maybe somewhere in there. And so we have an inequality now. When we graph a line with an equal sign, an equation with an equal sign is a line, a solid line, that's it. But with inequalities, we have shading. with inequalities, we have a whole range of solutions. So that's what's going to be different. Otherwise, it's pretty much the same thing as graphing a line. So the first thing we do is we want it in y equals mx plus b form, because that's how I'm going to graph. There's 3 methods to graph, and I'm going to do it this way. So we need the 3x to be on the other side. What will happen is it'll become negative 3x plus 4, so now it's in y equals mx plus b form. So I just subtracted 3x from both sides and stuck it in here. And so now we can see the slope. And now we can see the y-intercept. So the first thing we're going to do is graph this boundary line. So the y-intercept is the easiest thing to do first. It's at 4 on the y-axis, so I have a dot right here. Now we need to find one other dot, and then we can draw the boundary line. So we're going to use the slope to do that. Slope, I forgot to mention also, is rise over run. You might have heard that before. Rise over run, and our slope value is negative 3. I'm going to write that as negative 3 over 1 so that I can see that rise over run. So what we do is we start with this point that we graphed here, and we're going to use rise over run. 3 is negative, so I put the negative with the 3. You can put it with the 1 instead if you want. But if it's negative for the rise, you're going to go down 3. So 1, 2, 3, and then the 1's positive, and the run tells us right or left. So you go over here, 1 unit. And that's our boundary line. So next thing you have to do is decide whether it's dotted or solid line. I know it's solid because of this equal part here to the inequality. If I didn't have that, it would be dotted. So I'm going to try to draw a straight line, and it's solid through there, okay? So now I've got my boundary line. And next thing I do is shade. So to shade, I'm going to either shade on this side of the line or that side to complete my graph. I have to pick, and I have to figure out which way that I'm going to shade that's correct. So what I have to do is pick a test point. So what you do, I usually pick 0, 0 because that is easy to calculate, to put in an equation. And so here's my test point work right here. I'm going to write down my original inequality. And since I picked 0, 0, that point at 0, 0, I'm going to plug in 0, 0 here and evaluate this and see how it works out, because the left side needs to be evaluated. That pretty much makes 0. So 0 is greater than or less than, greater than or equal to 4. That's what I've got to ask. I'm looking to see if this is a true statement. Is 0 greater than or equal to 4? No. Okay. So that means I shade this way. If it was yes, I would shade to include that test point. And you can pick another test point anywhere else and plug it in, and you have to work it out and see if you get a true statement, and it tells you which way to graph. And that's how to graph an inequality. So I'm going to do one more. And you can look on YouTube for graph inequality, and I highly recommend that you look at this and look at somebody else explaining this, because it helps to reinforce it. Practice, 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 because you have more than one of these probably, and students get these incorrect. It's just a matter of lack of studying. Write down the steps needed to graph these kinds of things and take good notes. If you just have a bunch of numbers and stuff on a page, it might not help you. So my original inequality is here, and I want it in y equals mx plus b form because that's very helpful. The 2x needs to move over to this side, so all I do is subtract 2x from both sides. So it's going to be y is greater than or equal to negative 2x minus 3. And so I can see right here is my slope, if I just read it right off, and right here is my y-intercept. So my y-intercept's the first thing I graph because it's very easy. I go to negative 3 on the y-axis and make a dot. So I start to see where my line is going to be. I need one other dot to see how that boundary line will be. I'm going to use the slope to do that. slope is rise over run. And what I have is -2, so I'm going to put -2 over 1. So from that point, I'm going to go down 2, because that top number tells me up or down to go. So down 2, 1, 2, and the 1 is positive, so that's right here. So that's where another dot will be. And another solid line, because they have an equal part to that inequality. So I'm going to try to draw a straight line. And then I'm going to shade on either side and figure out which side by picking a test point. So I'm going to pick a test point other than 0, 0 and plug it in to my original inequality. You can pick 0, 0. I like doing that because it's easy to calculate. But just so you can see, I'll just pick a test point here. That test point is at 2, -1. So it's 2 times 2 minus 1 is greater than or less than -3. So that'll be 4 minus 1, which is 3. So what I'm asking myself, is 3 greater than or equal to -3? And the answer is yes. So I know to shade on that side. So all the solutions for that inequality is in that whole region, forever this way, all the way up to that line and on that line. Now, a totally different type of concept is domain and range. I don't think I have too many left. So domain and range is pretty easy, but you've got to remember that the domain are the x values. Somehow remember the domain's the x values and the range are the y values. And you're given a set of points. So I have 4 different problems here. You'll be given just one. And we're asked to state the domain for this set of points. You see them there? So since the domain's the x values, we're going to look for just the x values for part A and write those down. So that will be 0, 1, 5, and -7. And we actually really put those in numerical order. And then for the range, those are the y values. So I'm going to write down these numbers. I'm going to try to put those in numerical order. So this is how we answer this problem. So -2, 1, 3, 6. Okay? That's all you do is pick out the x values and pick out the y values. Same thing here. Now we're going to look at the x values. So the x values for these is 0, 0, 0, and 0. So actually we don't repeat any values that repeat. We just write 0 once. Okay, that's the answer for the domain. Now for the range, we have 0, -2, 6, and 1, the y values. So -2, 0, 1, 6. And then the x values for this is 1, 2, 5, and -7. So we're going to put those in order. None of those repeat. So -5, 1, 2, -7, sorry, 1, 2, and 5. And then for the y values, we have 1, -1, 6, and 1. So that'll be -1. The 1 repeats, so that gets listed once, and then 6. So for the domain, you might want to pause the video and just try this. You should maybe have paused it before and tried them yourself and see how you do. So we have 3, 1, 3, -9. So -9 first, 1, and then 3, and that's it because the 3 repeats. And then for the range, the y values, we have 3, -2, 6, and 9. So that will be -2, 3, 6, 9. And that's how you do those. Now we have a list of points, and I gave 4 problems here, and you're going to answer whether the relation is also a function. So a relation is, an interaction between two things. So we have x and y's going on, and we want to answer whether this is a function. So the answer to these are just yes or no. The rule for something to be a function is described so terribly in textbooks, I would totally ignore them always, and just remember this. For something to be a function, very simple. For something to be a function, all x values have to be different. That's all you need to know. It doesn't matter what's going on with the y values. Totally ignore the y values. So you just check, like in A, that the x values are different. We have 1, 3, 5, and 7. They're all different. So yes, this is a function that actually makes something workable. Doesn't matter what's going on with the y values. See in B, so we have in B 1, 2, 3, and 4, all the x values are different. All the y values are the same. Doesn't matter. If all the x values are different, that's a function. So you can try answering C and D, like pause the video. And so for C we have 1, -2, 0, and 9, so that's a yes. And then for D we have 1, 0, 3, and 0. The zeros repeat, so that's a no. All x values have to be different. Now we have a problem like this. F of x equals x squared minus 4. Find f of -3. This f of x is not f times x. It's actually, it looks like it, but it's totally just means a function of x. That means this is actually a function. This equation actually would work. Okay? Now we have this 3, if you notice, which is in that x spot for that f of x notation. So what we're going to do is plug in 3 everywhere we see an x for that equation and evaluate. So I took this and plugged in 3, that given value. So 3 squared is 9, 9 minus 4 is what we have, and the answer is 5. And that's all there is to that. I'll show you another one. So we have f of x equals -x to the third minus 2x squared minus 1, and we're given f of -2. So to find f of -2, we're going to plug in -2 everywhere we see an x. So I'm plugging in a -2 instead of x everywhere here. And every other symbol comes with that equation. So this -2 to the third is -8, so -8 goes right there. This subtraction or negative sign stays there. I'm going to put parentheses because it's, two signs next to each other. It's good penmanship to do that. And then we have -2 or -2, and then -2 squared is 4, so that's times 4 like that, and then -1. So next I'm going to resolve these signs, so that's a +8 minus, that makes an 8, minus 1, so that's really 0 minus 1, and so the answer's -1. So be real careful with those negative signs. Just plug in -2 everywhere you see an x and keep all the other symbols and everything there. In the next problem, use the graph to estimate f of -2. So I've got 3 problems here, and you'll be given just one, and this allows us to practice. So, this is your x-axis, this is your y-axis. F of -2 is in that -2 is in that x spot, right? So what we do is we go find -2 on the x-axis, which is right here. Okay? And we're going to write down the answer to this. This is number answer to these. It's actually very simple. So when you go, we're going to go up because the graph, the red line is up here, and see where that hits the red line. And then at that spot, we're going to see where that is on the y-axis, and that's at 4. So the answer is 4. Then for this one, estimate f of 0. So that 0 is in the x spot. So we go to 0 on the x-axis, which is right here. And we're going to go up because our graph happens to be up here, and see where that hits right there. It actually hits right on the y-axis, so we just read where that is on the y-axis, and that's at 2, positive 2, and so the answer is 2. Now you might want to pause the video and try the last one. I have another slide with 3 more of these too, a different graph. So the 5's in that x spot, in that f of x notation. So you go to 5 on the x-axis, which is right here, go down and see where that hits on that graph, which is right there, and then go over and see where that is on the y-axis, and that's at negative 2. So the answer is negative 2. That's all you do. Now here's another graph. And you can pause the video and try this one if you want. Just see how you do. You know there's one answer, number answer, that we'll put right here for each of these. Okay, so first estimate f of 3. So we have 3 in the x spot, so we go to 3 on the x-axis, positive 3, and we're going to go up because that's where our graph is, see where that hits right here, and read where that is on the y-axis, and it happens to be 3 as well. So 3 is the answer. For B, we have 0 again in the x spot, so we're going to go to 0 on the x-axis right here, and we're going to go down because that's where it hits our graph, and see where that hits on the y-axis, and that's negative 3. So we're right on the y-axis. That's what we're doing, is reading the y value in the end, so it's negative 3. Now this one says f of negative 10, so we go to negative 10 on the x-axis and see where that hits our graph, which is right here. And we're going to read where that is on the y-axis, and that happens to be negative 3. So the answer is negative 3. So now we start with systems of equations. I think that's might be the last concept I'll explain. So systems of equations mean 2 lines. We're going to be looking at 2 lines. Sorry, that should be straight lines. A system is 2 or more things working together. Excuse me. And so our goal is to find that point of intersection. And we do this 3 ways. We can solve a system 3 ways. Graphically, we can go and read that point right off, but we don't tend to practice that method in this course. Or algebraically, which is the substitution method, or the addition-elimination method. And you can find these explained on YouTube like crazy. It's a very common problem in algebra classes. So 2 lines can do that. They can cross somehow. They can even be perpendicular where they're crossing. They could cross, you know, just imagine you're holding 2 sticks. They can just cross in any angled way. Or they can be like this, parallel, where they never cross. And there's one other case that lines could possibly do in terms of the orientation. And they can be like this one, and then the other one on top of it, or it's the same line. There's really nothing on top, it's just the same line, but I drew that so you could see that. So those are the 3 things that lines can do as far as orientation. So we'll see that algebraically, actually, and I'll have to show you just the examples that I have, how that works. So here's an example problem. Find the solution to the system using the substitution method. So we're going to use the substitution method. That means we're going to take one equation and plug it into the other equation in order to solve. And what we want is our answer is going to be an xy ordered pair point. So our answer we're going to put right here, okay? That's going to be our answer. We're going to find what the x is and what the y is. So we're solving for x and we're solving for y. So here's your 2 system, it's one system, but here's your 2 equations. Y equals 5 minus 2x and 4x plus 3y equals 13. So the nice thing is that in the top equation, y is already solved for us. This is already like, obvious where y is by itself. So I can take that and plug that right into the other equation right here. So I'm going to have 4x plus 3y equals 13. I'm going to take that and plug in the other equation right in for y. So I'm going to put 5 minus 2x right in here. And what you see that we have now is one equation with one type of unknown variable, the x's. So we can solve for that x. So now we just work this out and follow the order of operations and everything. So the first thing to do is distribute that 3. So we'll have 4x plus 15 minus 6x equals 13. And so 4x minus 6x is negative 2x. We have to combine like terms if they're on the same side of the equal sign. And I have plus 15 equals 13. I'm working to get x by itself. So next I'm going to move the 15 and bring that way up here to work on. And so when I move the 15, I'm subtracting 15 from both sides. So I'm just going to show it that way. See that? It disappears on the left and appears on the right, and I would subtract it. So what I have is negative 2x equals negative 2. So x equals 1. So 1 goes in right here. So I found that part. Now we need to find the y, and you can guess how we're going to find the y. We can use either one of these equations and plug in our value for x that we found and solve for y. So I'll use the top one, y equals 5 minus 2x, and solve for y because I know x is 1. And so y equals 5 minus 2, y equals 3. So our answer is 1, 3. So we can see those two lines actually cross at some point. So our algebra showed us that we actually have a point of intersection. So they cross there. Next, we're going to use the solution, find the solution to the system using the substitution method again for this system. So both of them are solved for y. So since both of them equal y, we can actually just set them equal to each other because they're both equal to the same thing. So we set them equal to each other, and then we work to solve for x. So what I'll do first is subtract 2 from both sides. And so that's what I do. And so I can combine those terms there. So if 3x equals 7x minus 8. And now I need the 7x over by the 3x, so I'm going to subtract 7x from both sides. So 3x minus 7x equals negative 8, and that'll make negative 4x equals negative 8. So I can see x is 2 there. So my answer is 2 something. And so I can use either one of these equations to find the y, so I'll choose the top one. Y equals 3x plus 2, so y equals 3 times 2, the x value that we found, plus 2, and so that'll be y equals 6 plus 2, and y equals 8. That's my other part of the point, and so that's it. Those two lines cross at this point as well, at a point as well. So now I need to cover the addition elimination method. So we have 2x plus 3y equals 8 and 5x minus 3y equals negative 1. Sorry for my coughing. So the first thing that we want with this method is that the x values are lined up, the y values are lined up, and the numbers are lined up above and below each other on the other side. The second thing that we want to happen, we're going to end up adding these down the columns, right? We want one of these x's or y's to add up to 0. If both do, that's okay. So you can see, I'll just go ahead and write this here. 2x plus 5x is 7x. The 3y minus 3y adds up to 0. That's good. And then equals 7. So I have a little equation to solve. I can solve for x right away. I can see that's 1. So my answer is going to be 1 something. So now I need to find the y value. And I can use either one of these equations. I'll use the top one, I guess, and plug in the value that we found for x to find the y value. And so now I need the 2 and the 8 to be together on the same side, so I'm going to subtract 2 from both sides. So that's 3y equals 6. And I know 2 times 3 equals 6, so y is 2. So 2 goes here, and that's my answer right here. One more problem, and I have a thing to mention, and that's it. So here's another problem where we will find the solution to the system using the addition or elimination method. So the first thing is that my x values are lined up, that my y values are lined up, and that my numbers are lined up on this side of the equal sign. And that they already are as that comes, so that's good. The next thing I need is that when I add these down the column, one of these adds up to 0. They both can add up to 0, that's okay. But for the x's, I'd get 3x, and for the y's, I'd get 3y as it happens. Nothing with 0, so I need to make it happen. There's about 3 different ways you can do that. Sorry for the noise. What I'll choose to do, and I'll show you why in a second, is I'm going to multiply this bottom equation by -2. So I'm going to rewrite my system. I have 2x plus 5y equals 19. That top equation stays the same. But the bottom equation, I'm going to multiply each term by -2. So I'll have -2x, then -2 times -2y is plus 4y, equal sign, -2 times -4 is 8. Now the reason I did that is because now when I add them, look at what happens to the x's. Those are 0. So that's why I picked a -2, because I saw this too. And we have to make it happen then. And as long as I multiply every term by that number, then I can do that. So this will be 9y equals 27. So I have a little equation I can solve for y now. So y equals 3. So that gives me part of my answer, where y is 3. Now I have to find the x, and I can use the bottom original equation. I can use either original equation, plug in the value I found for y, which is 3, and solve for x. So I have x minus 6 equals -4. Now I need to add 6 to both sides. So I'll have -4 plus 6, and x is 2. So 2, 3 is the answer. And don't forget, you can search on YouTube for solving systems using the addition method, or elimination method, or the substitution method. There's a lot of instructors just explaining this type of problem as well. Now, you'll see some problems on vertical and horizontal lines. I highly recommend you look those up. These are some good videos here that I've picked out on vertical lines and horizontal lines. Definitely look at what's going on with those. Very important when you graph those. Otherwise, remember, the assignments due this Sunday night is just a quiz and a test. And you've got YouTube and my math lab as well. And that's all I have for you guys.